In computing, sound is represented digitally to allow it to be stored, processed, and played back on electronic devices. The process of converting sound into a digital format involves sampling the sound wave, which is inherently an analog signal. Sound waves are continuous and vary smoothly over time, but computers can only handle discrete data. To digitize sound, a technique called sampling is used, where the analog wave is measured at regular intervals, called the sampling rate. Each measurement, or sample, captures the amplitude of the wave at a specific point in time and represents it as a numerical value. The sampling rate is a critical factor in how accurately the digital representation reflects the original sound. It is measured in hertz, Hz, indicating the number of samples taken per second. For example, a common standard for high-quality audio is a sampling rate of 44,100 Hz, meaning the sound wave is sampled 44,100 times every second. The higher the sampling rate, the more closely the digital representation matches the original analog signal, improving sound quality. However, higher sampling rates also increase the size of the sound file because more data points are recorded. Another important aspect of digitizing sound is bit depth, which determines the precision of each sample. Bit depth refers to the number of bits used to represent the amplitude of the sound wave at each sampling point. For example, an 8-bit depth allows for 256 possible values per sample, while a 16-bit depth provides 65,536 values. A higher bit depth means finer gradations in amplitude can be captured, resulting in more detailed and accurate sound. It also reduces the noise and distortion that can occur during playback. Like sampling rate, increasing bit depth enhances audio quality but also increases file size. Several factors affect the quality of sound files beyond sampling rate and bit depth. One significant consideration is compression, which is often used to reduce the size of audio files for easier storage and transmission. Compression can be either lossless or lossy. Lossless compression retains all the original sound data, ensuring that the audio quality remains unchanged. Formats like FLAC and ALAC use lossless compression. Lossy compression, on the other hand, removes some sound data deemed less critical to human perception, significantly reducing file size at the expense of quality. MP3 and AAC are common lossy formats, suitable for streaming and portable devices. Another factor influencing audio quality is the presence of noise during recording. Even with high sampling rates and bit depths, if the recording environment introduces unwanted sounds or interference, the resulting digital file will reflect those imperfections. Proper equipment and soundproofing are essential for high-quality recordings. File format also plays a role in sound quality and compatibility. Some formats are designed for high fidelity, such as WAV, which is uncompressed, and retains the full quality of the original recording. Others, like MP3, prioritize small file size and compatibility with various devices, often at the expense of fine audio details. Ultimately, the quality of digital sound is a balance between these factors. High sampling rates and bit depths offer superior fidelity but require more storage and processing power. Compression can make files more manageable but may sacrifice audio richness. The choice of parameters depends on the intended use of the sound file, whether for professional audio production, casual listening, or efficient streaming. By understanding these principles, users can optimize digital audio to meet their specific needs while preserving as much quality as possible.